Okay guys, so in this next lesson, we're going to take a look at trig identities. So what you're going to need for this is your trig cheat sheet, and it's pretty much got everything that you need to know about trig on there. Okay, so we've already done our right triangles, um, some unit circle stuff, domains, and just general facts. Now, this is what's going to be important and what we're going to use for this lesson. So if you got a highlighter, I suggest you highlight the identities we're going to use the most. Now, we're not going to do double angle, half angle, sum and product identities. There's really not any use for it for calculus. Okay, so you need to know this section, tangent and cotangent identities. So tangent is defined as sine over cosine, and cotangent is defined as cosine over sine. We pretty much already know our reciprocal identities. Very rarely are you going to use these, and you'll see why in a little bit. Your Pythagorean identities. Okay, these are important. So we're going to use that whenever we see something squared in a 1 a lot of times. Okay, now I just want to go ahead and derive these out for you real quick so you can have this. If you see 1 minus sine squared of theta, that's equal to cosine squared theta. If I see 1 minus cosine squared theta, it's sine squared theta. And I'm just solving for each of those variables in there. If I see secant squared theta minus 1, tangent squared theta. Let's see what else. Cosecant squared theta minus 1 is equal to cotangent squared. Now, you are not expected to memorize all of these as we go through them. You will have this, but pretty much you will memorize them. Once we get to calculus, we're not going to use this that often. Use it a little more in Cal 2 with trig integrals, but we're not going to use it a ton, but you should know that tangent sine over cosine by the end of this. You should know sine squared plus cosine squared is equal to 1. Now, another one you might see a little bit down the road, we're not going to use it right now, but that one's an important one to make sure you memorize. Okay, and these are also on your trig cheat, your trig chart that we use. Okay, now the other page of this cheat sheet deals with the unit circle. So this is what your unit circle looks like. Remember, I was talking about how some teachers use the unit circle and make you memorize this, and we just use the trig chart. Okay, so that's your unit circle, and then on the back of this, we have some stuff about inverse trig, law of sines, law of cosines. We just did that. I've never seen that formula in my life. So just anyways, this is just some good information for you to do. This is from Dr. Dawkins at Lamar. So if you ever need any additional information, you can always print it off from his website. Okay, so what we're going to do is we're going to use our trig cheat sheet. And we're going to start with the simplifying trig expressions and identities practice problems. Example problems. So our first goal is to always try and simplify and get everything down to sines and cosines. Okay. So we know that sine of theta, we can't get that to sines and cosines because it's already in sines and cosines. Okay. Cotangent, I can write cotangent in terms of sines and cosines. It's cosine of theta over sine of theta. Now, when we do this, these will end up canceling, and so we're left with cosine. This section is called simplifying. When we do trig identities, you're going to have what it equals to on the right side, and you have to prove how you got that answer. Okay, the next one. We got sine squared, cosecant, and a cosine. Okay, so we're going to leave the sine squared alone. I can rewrite cosecant as 1 over sine. So I'm going to rewrite it as 1 over sine of theta and I still have the cosine on the bottom. Now, I can cancel one of these signs, okay? So sine cancels there, and I'm left with 1, sine on top. Now, from our trig identity sheet, we see that sine over cosine is equal to tangent. Okay, so our answer is tangent of theta. Okay, the next one. We got cosecant squared times 1 minus cosine squared. Now, there's two different ways we can approach this problem. We can approach it by distributing, or we can approach it by simplifying something first. Now, 1 minus cosine squared, if we go to our identity chart, 1 minus cosine squared is equal to sine squared. So we're going to substitute right here. This is sine squared theta. Now, cosecant squared, we can write that as 1 over sine squared. And I have a sine squared, x. Let's use x. Need to make sure our angles are right. Over 1. Now, we have sine squareds on top and bottom, so we can cancel that. So this just goes to 1. Make sure that if something cancels top and bottom, it always goes to 1. Okay, the next one. We're going to do sine of x, and you got cosecant of x minus sine of x. Now, between these two problems right here, I saw that I could simplify 1 minus cosine squared first. Okay? In this example problem, I'm probably going to distribute first because I can't simplify on the inside of the parentheses. Okay? So sine of x times cosecant of x, and sine times sine is sine squared of x. Now, the next thing is to get everything down to sines and cosines. Cosecant can be written as 1 over sine of x. The sines will end up canceling, so I'm left with a 1. So 1 minus sine squared, go to my identity sheet, 1 minus sine squared is cosine squared. And that's what my answer is. The next problem. Okay, so this looks like it's going to be a little more complicated. So, when I see a 1 plus something, squared 1, and no, this is just from my experience, you're probably going to have to use a Pythagorean identity, okay? So, I can substitute for cotangent squared. Cotangent squared is cosecant squared theta minus 1. Right? Now, this is difference of squares, okay? So difference of squares, remember it factors to cosecant of theta plus 1 and cosecant of theta minus 1. And those will end up canceling like that. Okay? Now, we're left with cosecant of theta minus 1 on top, sine, and then I can turn this cosecant of theta into 1 over sine of theta. And that will end up canceling. So we're left with cosecant of theta minus 1 plus 1. The 1's will end up canceling. So your final answer comes up to be cosecant of theta. Now, would I expect you to know how to do that? No. This is just a little bit different strategy on this. The reason I know is because I've worked a ton of these problems, how to do it. So you just have to work a lot of problems and you start trying to figure out where to go from there. Now, what I'm going to say is there's multiple ways to do some of these problems, but you have to make sure your work makes logical sense. So whenever I go to grade your test or your quizzes, they have to make logical sense that I can follow, okay? So sine of theta plus 1 and sine of theta minus 1. So we're going to distribute. So sine squared, so we'll FOIL it out, minus sine of theta plus sine of theta and minus 1. Now, sine squared minus 1 is not on your identity sheet. Our identity sheet looks like this. Sine squared plus cosine squared, theta is equal to 1. So, if I was to solve for sine squared minus 1, I would subtract the 1 to this side, and I would move the cosine squared to the other side. So it's equal to a negative cosine squared. And that's how we do that one. And that is the end of the first set of notes. So as you work through these problems, some of these problems are going to be super easy. Don't get frustrated with them. It's just something you have to go through. And most of you are going to hate this. It's okay. But we have to do it. Make sure you write neatly and make sure your work makes sense. Work in a logical fashion. Hopefully you have a good afternoon. Thanks.